So we left off yesterday on problem number 4, where we were taking a statement, writing the hypothesis and the conclusion, and then rewriting the statement as an if-then statement. And we started with this statement: 4 quarters can be exchanged for a $1 bill. We said the hypothesis is that you have 4 quarters because you have to start with something. And then the implication is if you have the 4 quarters, then you can exchange those 4 quarters for a $1 bill. So our conclusion, you can exchange your quarters for a $1 bill. And then our if-then, if you have 4 quarters, then you can exchange your quarters for a $1 bill. Looking at the statement in part B, it says the sum of the measures of 2 supplementary angles is 180 degrees. The sum of the measures of 2 supplementary angles is 180 degrees. This part right here would be my hypothesis. 2 angles are supplementary. All right. Let's try a different one then. Let's see if that one works. Two angles are supplementary. My conclusion would be the sum of 2 angles measures is 180. So my if-then would be if 2 angles are supplementary, then their sum is 180 degrees. If 2 angles are supplementary, then the sum of their measures is 180 degrees. All right. Let's see what we can do with part C. Part C says a polygon with 2 sets of parallel sides is a parallelogram. What would my hypothesis be? So we want to take this idea, we have a sentence that has 2 pieces to it, and we want to break it apart into 2 separate sentences. So we have what? Yes. A polygon with 2 sets of parallel sides. So I'm going to say a polygon has 2 sets of parallel sides as my hypothesis. A polygon has two sets of parallel sides. What's the other idea that we didn't grab in that sentence that was part of the other sentence? Is a parallelogram. So what would be the parallelogram? What would we be referring to? What was the subject of the sentence? A polygon. So a polygon is a parallelogram. So what would my if-then statement be? Parallelogram. Yes. So the only thing that you were missing was the word then, right before you said it is a parallelogram. That's the only thing that you missed. Other than that, that was absolutely perfect. Fantastic work. If a polygon has two sets of parallel sides, comma, then it is a parallelogram. Beautiful work. Absolutely beautiful work. All right. Go ahead and flip over to page 6 for me. We're going to extend our conversation about if-then statements to talk about different forms of an if-then statement. The converse is formed by exchanging the hypothesis and the conclusion of the conditional. So for the converse, we are going to switch. Converse, we're going to switch. So our original conditional statement was, if it rains, then the parade will be canceled. My converse would switch around. If the parade is canceled, then it rained. So we switch the hypothesis and the conclusion for the converse. The inverse is formed by negating both the hypothesis and conclusion. So for the inverse, we leave things in its original order, but we put not with the hypothesis and not with the conclusion. So instead of if it rains, then the parade will be canceled, it becomes if it does not rain, then the parade will not be canceled. Looking at these nots here. This is what makes it the inverse. And then finally, we have something called the contrapositive. And the contrapositive, we do both what we do with the inverse and converse. We do not with the hypothesis, not with the conclusion, and we switch. Not with the hypothesis, not with the conclusion, and then we switch. So we negate both the hypothesis and the conclusion of the converse. All right. So I want to try our hand at these. So again, inverse is not. Converse is to switch. Contrapositive, we do both. So let's look at number 5. We're going to write all of these in if-then form. The tang is a saltwater fish that inhabits shallow coral reefs in tropical areas. Tangs are part of the, I'm not even going to try that word, family, along with surgeonfish and unicorn fish. All members of that family are saltwater fish. Write the converse, inverse, and contrapositive of the true conditional statement, tangs are fish that live in saltwater. So we need to take the statement, tangs are fish that live in saltwater, and we need to turn it into an if-then so that we can write our converse, inverse, and contrapositive. So I'm going to change this statement to say, if a fish is a tang, then what? I'm taking this sentence here and changing it into an if-then. So if a fish is a tang, then what? Then it lives in salt water, yes. Then it lives in salt water. All right, so there's my if-then. So I'm going to cross this out because we're going to use our if-then to write the converse, the inverse, and the contrapositive. And we said that this was a true conditional statement. All right, so the converse. What do we do for the converse? Look up at the top of the page if you need a reminder. We switch. So converse, we switch. So instead of if a fish is a tang, then it lives in salt water, what happens if I switch my hypothesis and my conclusion? Not my if-then. My if still stays at the beginning. My then still stays in the middle. Yes. That's perfect. Yes. If a fish lives in salt water, then it is a tang. Is that true or false? If it is a fish that lives in salt water, does it have to be a tang fish? No. So this would be false. So let's think up a counterexample then. So I would need a counterexample that makes the first part of the sentence true. I need a fish that lives in salt water, but the second part of the sentence to not be true. So I need a fish that lives in salt water, but is not a tang fish. So what's another example of a fish that lives in salt water, but is not a tang fish? What's an example of a fish that lives in salt water? Unicorn fish. A unicorn fish lives in salt water, but is not a tang. All right, so that's our converse. Inverse, we don't switch. What do we do for inverse? We put not with the hypothesis and the conclusion. Do you have a notes packet? Okay, go ahead and pull your notes packet out and put your phone away, please. For inverse, We put not with the hypothesis and not with the conclusion. But we do this from the original conditional. So I'm going to go all the way back to my original conditional. If a fish is a tang, then it lives in salt water. What would the inverse look like? Mm-hmm. That's perfect. If a fish is not a tang, then it does not live in salt water. If a fish is not a tang, then it does not live in salt water. Is that true or false? If a fish is not a tang, that is false. So I need a counterexample then, since we said it was false. So I need an example of a fish that is not a tang, but that does live in salt water. We could do unicorn fish again. I can use the exact same counterexample from the previous one. That is something that is not, or that lives in salt water, but is not a tang. So a unicorn fish lives in salt water, but is not a tang. All right, then what do we do for our contrapositive? Yep, we do not, and we switch. So it's going to look kind of like my Converse, because that one's already switched, but with not and not. So my Converse, but with not. So if a fish does not live in salt water, then it is not a tang. If a fish does not live in salt water, then it is not a tang. If a fish does not live in salt water, could it be a tang? If the fish does not live in salt water, we have a fish that lives in fresh water. It does not live in salt water. Could that fish be a tang fish? No. So is this last statement true or false then? This is true. If it doesn't live in salt water, then it can't be a tang fish, because tang fish have to live in salt water. Nicely done. Let's try another one like that. Symphony orchestras contain instruments from 4 musical families: strings, woodwinds, brass, and percussion. However, string orchestras only contain string instruments. String instruments include the violin, viola, cello, bass, and harp. Write the converse, inverse, and contrapositive of the true conditional statement. If an orchestra is a string orchestra, then it contains string instruments. Determine whether each related conditional is true or false. If a statement is false, then find a counterexample. So it said that my conditional statement, my original conditional statement, is true. If an orchestra is a string orchestra, then it contains string instruments. What do we do for the converse? Switch. So what would my converse sound like? That's okay. I would start with the first part. If an orchestra contains string instruments is what I would do for that one to get it to sound right in English. If an orchestra contains string instruments, then what? Remember, we're switching our hypothesis and conclusion. Then it's a string orchestra, yes. If an orchestra contains string instruments, then it is a string orchestra. If it contains string instruments, then it is a string orchestra. And with the way that sentence is written, if we decide that this is true, then there is no other kind of orchestra other than a string orchestra that contains string instruments. We're saying if it contains string instruments, then it has to be a string orchestra. Is that true or false? That is false. I think they gave an example of another kind of orchestra up at the top of this problem. What did they say? What other kind of orchestra did they? What other kind of orchestra did they talk about? A symphony orchestra. Does a symphony orchestra have strings? Yep, contains strings, woodwinds, brass, and percussion. So a symphony orchestra has strings, but it's not a string orchestra, right? So my counterexample would be a symphony orchestra contains string instruments a symphony orchestra contains string instruments. So that's a different type of orchestra that is not a string orchestra. You with me, dear? All right, for inverse, what do we do for inverse? Not. So I'm going to go back to my original conditional. If an orchestra is a string orchestra, then it contains string instruments. How would I write the inverse? Yep. If an orchestra is not a string orchestra, then it does not contain string instruments. That's absolutely correct. If an orchestra is not a string orchestra, then it does not contain string instruments. If an orchestra is not a string orchestra, then it does not contain string instruments. So let's think about whether this is true or false. So let's think about the first part. If an orchestra is not a string orchestra, have we talked about any other kinds of orchestras? What did we talk about? Symphony orchestra. So I could think about a symphony orchestra right here, right? Because that would meet that first part, not a string orchestra. Then it does not contain string instruments. Is that true? No. So this would be a false statement. And what could I use as my counterexample? I already used it once. Yep, I can use the symphony orchestra. A symphony orchestra contains string instruments. All right, what do we do for the contrapositive? Not, and switch. So I'm going to look back at my Converse, the one that I've already switched, and we're going to not this one. So what would that sound like? That's perfect, yes. If an orchestra does not contain string instruments, then it is not a string orchestra. Is that one true or false? If you have an orchestra that does not contain string instruments, could it be a string orchestra? So is this statement true or false? This statement is true. My original conditional and my contrapositive will always have the same truth value. If the original conditional is true, then the contrapositive will be true. The inverse and the converse will always have the same truth value. If the converse is false, the inverse will be false. It's possible for all of them to be false. It's possible for all of them to be true. But the converse and inverse will always be the same, and the original conditional and the contrapositive will always have the same truth value. All right. The homework that you guys picked up on your way in the door is due on Friday. This is something that you can go ahead and get started on. We started working on conditionals and if-then statements yesterday, and now we've talked about the converse, the inverse, and the contrapositive. We'll talk about biconditionals tomorrow, and that'll be the rest of what you need for that homework.